I literally have never operated an automated machine before, and I'm about to program this thing. This is gonna be hard.
All right, calm down. This is nowhere near as bad as what you think it's gonna be. For everybody tuning in, what we are standing in front of here is the Robo-IQ from Vapor Honing Technologies. Again, Graycen's never done this before. I have some experience myself. And what we are looking to do is go in and teach one face of this part here and completely blast it. We're gonna walk through each step together. That way you actually understand what's happening, and that way you guys also learn at home. So let's hop into it. All right, so to go ahead and get started, what you are holding right now is the teach pendant. That's how you control everything that's happening inside of the cabinet itself. So you'll be able to control the arm from there, the blasting operation from there, the turntable from there. That's your interface for everything. On the side of the cabinet here is the only other thing to note. So there is a switch. It's to orientation. So right now we're to the left and there's no light. That means we're in program mode. What program mode means is that the robot arm itself can move, but the turntable and the outputs cannot fire. So as soon as we turn this back to the right, you'll see that we get a blinking light and you're gonna get an error message. That's actually an emergency stop. What that's telling you is that you're trying to enter the run mode, but it can't because the door's open. When we're actually ready to run, that's when we'll flip it back. That allows you to have full turntable movement, and it also allows you to have your outputs such as your pump and your blasting air fire. Just in case you see that in the future, that's where that comes from. Now, when you're actually starting to program, what you want to do is make sure that you're at home. So inside of your demo program that you just created, we can go ahead and call for the turntable to go to the home position, and we'll set a home position for the robot. That way we have a good starting point for the rest of our program. On the teach pendant, the way that you're going to call for the servo to move is you're going to use a custom code, so you can go ahead and click that. So inside of the teach pendant, command is where you select which option you're looking for. This is where you'll define your moves. You can also do repeats in here, which we'll use in just a minute. Inside of the property is where you actually edit the command that you've selected. So when you actually have this, there is going to be a demo program that's completely set up when you receive it. All the homing of the turntable does is bring it back to the exact same position every time. So it's going to index your part. What that's really good for is if you have something like, let's say you're doing a turbine blade that's in there and you have it on a fixture, you can verify that it's going to start blasting at the exact same spot every time by calling the turntable home.
Okay.
So now we can go ahead and set our home position for our robot. How do you think you would do that?
Make another custom code.
So it's actually not a custom code, and I'm glad it's not. So inside of the teach pendant, you have different types of moves. We're gonna go ahead and do a move J. J stands for jog. That move interacts directly with the joints of the robot. That way it reaches the same position every time. Go back into property, click get position, and you're gonna see all the boxes fill underneath it. Okay. Scroll up, type in home. That way we're setting a home position. Enter. Sweet, and that's confirmed. You can see, so it goes from gray to green over here to let you know that it's actually activated. Okay. So now when we run this, you're gonna see the turntable move to its home position, but you actually will not see the arm move because we set it to the position that it's currently in. When you click get waypoint, you're setting it to the position that the robot's currently in. Okay. Then you can go ahead and put it back in the program state. That way we can open the door and just look at it and not get an error. We'll open this guy back up. So that is your home position. When you're selecting a face, knowing how many degrees off from that home position you are is very important. So there is a notch here that you can line up with your fixture plate. In between each one of these is 15 degrees. So we can actually count out to what face we want to go to. All right, so now that we are at our home position, we know that it's going to start from here every single time. So we can calculate how far to that face you're wanting to blast is. It's looking like it's going to be about 255 degrees. Everything on the turntable is done in degrees. Remember, you've got 15 degrees in between each slot. That way it's really easy to calculate. That's the number that you actually give the teach pendant to move the servo. So if you want to go ahead and type 255 into that and click confirm, and you'll see it, did it turn green? Mm-hmm. Perfect. All you're going to do is click play. It's going to ask you to save it. Click save. click Real Mode up top. Yep, and click Play. So that's exactly how we're going to be teaching points inside of this thing. You're actually able to move the robot where you want it, set that point, and iterate to it. You're literally just going to press Get Position, and then Confirm, and it'll make it as green. So now when we run it, that's what it will do. Now alternatively, if you did not want to physically move the robot to each position, you also have a jog function, which you'll see in the bottom down here. So you can go inside of there, and it gives you two different options when you're actually interfacing with the machine. You can move each joint specifically, or you can go to the task setting and you can move it on the XYZ plane. This is really nice if you're trying to do consistent blasting swipes. The joint movements are very nice if you're trying to get into a difficult position where you have to take into account each portion of the arm. So literally there, like for instance here, we'll go down. Now what you want to do is actually go back to your home position right here. And you can click Move To, but it'll actually make sure that it's going to complete that movement without crossing any singularities. Then we can go back to that position. You can hold that. What I like to do is just copy the move that you're on and then paste a new one below it. You can edit the name, but before we do that, we'll just go to the Jog tab, and we're just going to move it on the Z axis. So that's going to get us all the way up to the top of our part. So you can go ahead and X out of there, go to the new, which it should be there when you're in, Get Position, and you'll want to rename it. Now from there, to make the most use out of our turntable, what I think would be easiest is you're just going to basically repeat these 2 points, bounce back and forth between those two, and we're going to move the turntable 1 or 2 degrees in between each pass. That way you get full part coverage on that front face. If you go under Command, we're going to add in a repeat. That way we do the same movement over and over again. And we'll go ahead and go under Property and give that a name. That way we can actually edit it. Just call it like F1 for face 1. And you'll see we're green now. So we can actually multi-select those that we've already made. Cut them. And we can paste them back inside of our repeat. Let's go ahead and turn the repeat on. For now, just do 5 on that repeat. That way we can do some testing. So your end value here is going to be 5. Go ahead and confirm that. Now we can actually copy this index that you have from up there, put it here, paste it in. You can put that at 15. Go ahead and confirm that. Then from there, let's go ahead and edit that top variable. The 295, we'll change it down to like 215-ish. Confirm that. Go ahead and press play. It's going to ask you to save it again. Make sure we're in real mode. And you're ready to roll. Think about where you need to turn things off and on at is if you're doing any sort of homing move, you're going to want to make sure that all of your outputs are off when you're actually in position. That's of course when you turn them on. So after we get our turntable where we want it to with this servo movement here, we can actually go into commands, get a set command. It's right there. Go back into property. So as you can see inside of your set command, you are on the pump and it is set to on, which is actually what we want. So we can go ahead and actually copy that command there and paste another one directly below it. There we go. So you can go ahead, where you've selected pump, we'll also want to turn the blasting air on. There we go. And it's already set to on. And you can go ahead and confirm that. So now for our actual blasting procedure, we've turned the pump on, which of course is going to start agitating. Also, when you turn the pump on this machine, it's going to activate the demisting unit up top, and it's going to close your overflow valve, the way you don't lose any media. Both of those are on timers, that way you do not have to worry about them, and we can continue on with teaching. Not bad. What you think?
I think it looks really good. It was really easy to learn how to do this too.
How many points was that? Like total, the program's probably 20 lines of code?
Yeah, 21.
Was it 21? Yeah. Technically 4 movement points, I think, is all we had to do. Now, to revise, to try and get this side a little better, because we did a very good job over here, we could always go back, tilt the blast gun a little bit over, and do a second repeat. But for your first go on this face, that looks really good. So do you think if I was to just hand this to you now, you could program this by yourself?
I think I probably could. Now that I messed around with it, it's super easy to navigate. It's kind of like a computer, because now I know where everything is.
What would you say the most challenging part of this was?
I'd probably say the custom codes, but if we were using a template, it'd be easier to remember.
Absolutely. What would you rate it on a scale of 1 to 10 as far as difficulty, with 1 being super easy, 10 being very difficult?
I thought it was gonna be like an 8. I thought it was gonna be really, really difficult and I was gonna be confused, but it honestly was like a 3 or a 2 even.
Really? All right, so to wrap this video up, I just want to talk a bit about what this machine is used for and how it should be implemented. In this demonstration, we do have a very large part in here, and this thing is more than capable of dealing with those large parts with complex geometry, as you see. Another good use case for this machine is that it can be used for multiple small parts, and you can index between those. It is very easy to get in here and teach this thing, as you saw. We did the entire demonstration that you saw today within 20 lines of code. And we do provide you with ample documentation on how to get up and running, as well as training. That way, as soon as you get this thing, you can get up and running. We like to consider this adaptive automation here, meaning no matter what your part is, you can put it in here and get highly repeatable, consistent results. That is the goal of this machine. Now, again, to explain exactly what this thing is capable of, using the part that I gave earlier, if you are using an aircraft turbine blade, for example, you can set it in, make sure you have some sort of jig, which we can create that jig or base plate. That way you can have that part in the exact same spot every time. Take your arm, teach your waypoints, rotate to the other side, teach your waypoints, and now you have a complete recipe for that part. Now, additionally, we can set up recipes depending on the part height. So if you have variations in your turbine blade, we can change it to where it will only move up to a certain height, and we can also do standoff distances inside of the same program. So I hope this video was a good demonstration of how easy it is to interact with this machine. Again, we did this entire recipe with 21 lines of code, I believe. This is a very good example of something that you would actually be blasting inside of here. It is very easy to just move around the part, completely teach one face, then rotate to the next. So to recap, what this machine is it's a highly adaptable automated machine, meaning if you have large parts that you want to put in here, you can easily teach those. If you have multiple small parts that you're wanting to move and then index and blast, you can easily accommodate that in there. We actually just had a project recently, but this thing is very adaptable. It is very easy to set up and teach, and it is something that you can implement very quickly inside of your business.